Hello, and welcome to Unit 1, Section 2, Domain and Range. So, let me get my pen, get a black pen, there we go. Finding the domain of a function defined by an equation. So this is some notation you guys would have learned previously. We're just going to review it really quick. So remember that you have a parenthesis when your endpoint is not included. Or when you have negative infinity or positive infinity. The bracket means your endpoint is included, so that's similar to a solid circle, if you guys are familiar with the circular notation. So here on a number line, x is greater than a would be anything greater than a. Less than a is anything less than a. Notice that these lines underneath indicate inclusion. So it is included. That would be an inclusive. Notice here you can mix endpoints, being included and not being included. That's totally fine. So remember, your domain is your input values, your sets of x's. Now we have it in a list. So our domain would be the first in every single ordered pair. So we can say the domain is -5, 0, 5, 10, 15. That is your domain. And that's how you would write it if you were given a list. So give the domain of this function. So we need all possible values that I can put into this function. So we can think about it like this. Can I put in positive values for x? And so x cubed, is that a real number? Does that give me a real number? It does. What about negative values? Think about -3 cubed. Does that give me that does give me a real number. So anything with decimals, can I cube anything with decimals? Yes, I can. What about fractions? Yes, I can. So it looks like the domain is all real numbers because I can really put anything in there and I'll get a number. So we're going to find the domain of this function. So we need every x value that we can put in here that will give us a good y value. Now, this is a fraction. So one thing we cannot have is 1 over 0. So I know that 2x minus 1 can't equal 0. Right? So that 2x minus 1 has to be greater than 0, or 2x minus 1 has to be less than 0. So now I'm going to solve these. I'm going to add 1 to each side here, which gives me 2x is greater than 1. I'm going to add 1 to each side here, which gives me 2x is less than 1. I'm going to divide by each side by 2, and since I'm dividing by a positive number, I don't need to worry about switching the signs, which gives me x is greater than half or x is less than half. And that is my only restriction here. Since my top number is allowed to be 0, it's allowed to be whatever it wants. My only restriction on my domain is the bottom number. So that means it's going to go from negative infinity to half, unioned with half to infinity. And it does not include that half. Now we're going to find the domain of this function. Now it looks like this function it'll be a square root. So what does that tell me? Well, I know for a square root that it's a square root is what happens, and this is a hard one to describe, right? Because everybody knows what a square root is. So a square root is when you take the product of two numbers, of one number multiplied by itself to get that one number again. So it's when you take this. So that's kind of what that means. Now, you need two of them. What can I not have under a square root? It can be 0, right? But 5 plus 2x has to be greater than or equal to 0. So it cannot be negative. I cannot have a negative under a square root. I can have a negative under a cube root, one with a little 3, but I cannot have it with a square root. So that would be like this. Square root of negative 25. There is no number when you multiply it by itself that will give you negative 25, right? Because if it were a negative 5, you'd have to multiply by a negative 5, and that would still be positive 25. The only way that would work is if it were 3 of some number, because a negative times a negative times a negative will give you a negative. So you can't have a negative here under a square root. So now I want somewhere where 5 plus 2x is greater than 0. So I'm going to subtract the 5 from each side. Then I'm going to divide by that 2. So that gives me x is greater than or equal to negative 5 over 2. So it's equal to, so I can use a bracket. This is the equal to one. And then it's going to be greater than that. And it gives me no upper bound. So I'll go with infinity. So these are some different types of notation. So this is interval notation, like what we were just doing previously. This is set builder notation with squiggly brackets, which are these curly little braces you see here. And that says this is our defining variable, h, in front, right here. And then this is similar to such that in the English language. H is greater than or equal to 10. And this would be h such that, so h such that h is greater than 5 and less than 10. So set builder notation and interval notation are some very common notations that we will use. Set builder, you'll definitely see that in your higher level classes. So it's a good idea to know what it is. The interval notation will be mainly used here. That's what we use a lot in the lower level math classes. Given this figure, specify the graphed set in words. So words, this is, notice right here, that was white, right here, that's what we're looking at. So in words, this would be something like our value is less than or equal to 2 to negative 2, or equal to 1 but less than 3. Notice we don't say that 3 is included. Yeah, that looks good. So in B, set builder notation, this would be, we're just going to pick a random one. What do we want? What alphabet does not get chosen very often? We'll go with J. J. So J, such that J is greater than or equal to less than or equal to negative 2, right? So we would say that J is less than negative 2, or J is greater than or equal to 1 and less than 3. I'll rewrite this one. Let me erase the rest of it. Okay. We'll say J is less than or equal to negative 2. Looks good. Okay. Now, interval notation. You would have negative infinity, negative 2, include negative 2, unioned with including 1, comma 3, don't include that 3. Finding the domain and range from a graph. So let's say we have this function, or we'll go with this weird one again. So the domain, let me see. This right here, all of those values, that's your domain, those x values. Now your range are these guys. And they will be your range. So those are your outputs. So the domain is all of the numbers that you can cover and the range is all of the numbers you can cover along that range. I know, such a weird way of explaining it, right? Going in circles here. So I'll show you. Identify the domain and range using interval notation. Now we're going to identify the domain and range. So it looks like the domain, let me get this. So remember, we have our domain runs along this way. So it looks like this is our domain, and then it's going to go to 2000, right? So our domain, and it will include, 1950 to 2000. Oh, that'll be a comma. That's our domain. Now what about our range? So our range is these values on here. So we're looking for here to, that's the lowest point on the graph. That looks like about 47. We'll say it's about 47. That's fair enough. And this one looks like the highest, which is about 90. So this is our range, these areas in between here. So it includes 47, and it goes all the way to 90. So that's our domain and range from the graph. So we're going to find the domain and ranges of the toolkit functions. So one we have is the constant function. And remember, that was just any function there. So the domain here is all real numbers, or positive infinity to negative infinity. And the range here is just going to be C, your number, whatever your constant number is. Now we're going to look at the identity. That's the one that looks like this. So the domain, I can put in any real number that I want, and that will give me a good number that will be in my range. And as a consequence, my range can be any number. Sometimes negative infinity to infinity will be referred to as R, which is all real numbers. It's an easier way of writing it. Now we are going to look at the absolute value function. Right? So it looks like along my domain, I can put in any number I want. My range, though, see how I have nobody on this part of the y-axis? I'm allowed to have 0. So my range is going to be 0 to infinity. Now what about quadratic? So that's x squared. This was x. So that's something like a parabola, right? So what's my domain? Well, anything. You could put anything into it. And what is my range? Notice that I won't get anything negative. I will still get a 0. That's my range. Now what about cubic? Looks something like this, right? So notice my x values along my x-axis. I can literally put in any number I want. That'll be okay. So my range, now I'm looking at these guys all the way up and down here. And it looks like I can take on any value. So that's also going to be all real numbers. Now let me insert a new page. There we go. So now we are going to look at a square root function. So that would look something like this. So now notice that my domain, notice that I don't have any x values over here. So I can only have 0 to infinity. And my range, notice how I don't have any negative y values. So my range goes from 0 to infinity. So it's just the positives. Now, what about a cube root? So that would be something like this. Something like this. Or not here. Here. There we go. So now what do you notice? Well, according to my domain, I can put in any number I want, including the negatives. And according to that y-axis, the range, I can actually get a negative, so I can have whatever I want there. Now what about the reciprocal? That's 1 over x. It's going to look something like this. So notice, we talked about how there's a hole here, about how you can't actually reach x equals 0 because then you have 1 over 0. So here, that means that this is what we have for our domain and our range. Notice that it cannot equal 0. Since there's a 1 on top, we're never really going to get anything to equal 0. So it's going to be negative infinity 0 unioned with 0 infinity. Now as a little exercise on your own, it's not going to be do or anything. Determine the domain and range of 1 over x squared. That'll be fun. All right, so now we're going to apply what we just did. So find the domain and range of negative square root 2x minus x. So the, let me see, the domain and range. Well, we can start plotting points. That's usually a good way at this level. So I'm going to have x equals 1 and my y, so that means that I get 2 minus 1 is 1. So the square root of 1 is 1 and it's negative 1. Let's try 2. 2 minus 2 is 0 and the square root of 0 is 0. Make that negative, negative 0. Negative 0 doesn't mean anything, so we're just going to go with 0. Now notice anything less than 2 gives me a negative number and I can't work with that. So I've got to start going smaller than 1. So what about 0? 2 minus nothing is the square root of 2, negative square root 2. 2 minus negative 1 is 2 plus 1, which is the negative square root of 3. What about negative 2? 2 minus minus 2 is 2 plus 2. So that's negative square root of 4. So that gives me negative 2. And I can start plotting these. So when my x is 1, I'm just going to be approximate. Here's 1. My y is negative 1. So this is my point. This is my first point. When x is 2, my y is 0. Okay. When x is 0, my y is negative square root 2, which I think will be somewhere around here. When my x is negative 1, it's going to be a little bigger than that. When my x is 2, it's going to be a little bigger than that. So it looks like I'm going to have something that looks like this. Now my domain. So it looks like, of course, 2 minus x can't be less than 0. So it looks like my domain is going to include 2. I might want to write it the other way. It's going to go from negative infinity to 2, and it's going to include 2, and it's not going to go any higher than 2. Now my range. Notice that I have my y can equal 0 right here. I have no positive y values. So my range is going to be negative infinity, 0. Okay, graphing piecewise defined functions. A piecewise function is one that you guys have probably already seen before, but they'll look something like this. You know, just multiple pieces. And when they are defined, it will look like this. You know, x plus 1 for x less than 0, x minus 2 for x between 0 and 4, and x squared between less than or equal to 5 and 4. You know, something like that. That's a piecewise defined function, and they always have multiple domains. So graph the following piecewise defined function. So here for x, this first one, so when x is less than negative 1, then we get our function is x cubed. So let's try x equals negative 2. So let's do negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. And I'm breaking it up according to these boundaries. It looks like it's going to go from negative infinity to positive infinity. So let me see. And so we'll do 5 because we need something greater than 4. So for anything less than negative 1, not including negative 1, it's going to be x cubed. So what is negative 3 cubed? Well, that's going to equal negative 3 times negative 3, which is 9, times negative 3, which is negative 27. So it's going to be way down there, not really on our graph. Now what about negative 2 cubed is going to be negative 2 times negative 2, which is 4, times negative 2, which is negative 8. So we'll pretend that this is somewhere down here. Now, where is it going to be at negative 1? It's going to be at 1. But remember, it's not equal to 1. So it's got to be an open square. Or an open circle. And here we'll say this is 1. an open circle. And if you look up the graph of x cubed, you know it's going to go something like this, sort of like a parabola, skinnier parabola. But the other side goes upward. Now we only want one side of that. So if x is between 4 and -1, not including 4, -1 or 4, it's going to, y will be -2. So let's say this is -2. So now we've got something that looks like when x equals, this will continue, when x equals -1, y equals 1. This will need to be moved to right here. There we go. Sorry, guys. So now it's going to go from here all the way to here. It's just a straight line across. And then when it's greater than 4, so it's going to be square root, it's 4 and that's equal to 2. But remember, it's not equal to greater than or equal to 4. So that means it's not going to be equal to 2, so we're going to need an open circle. Let's see, that's 2. Right here. So now it's just going to go off in this direction somehow. So wow, that was a doozy, huh? So that's the way you graph these piecewise functions, is you have to graph them on the intervals they are given. And it will take a while, and it will also take a lot of practice. So if any of you guys are choosing to use the OpenStax pre-calculus book, please do practice. Practice makes perfect. That about sums it up for section 2, domain and range. And I will see you guys in the next one.